This is the lesson for Unit 7, Objective 1, which is really 3.9 in the book. But for us, because we're doing our lessons in a little bit different order, this is really our Unit 7, Objective 1. So what we're working with is circles in the coordinate plane. And so just a couple of things that we need to pay attention to is the key concept and essential understanding that they're talking about. So most importantly, this geometric definition here is the one that we really need to kind of understand to be able to figure out where did this formula come from. So we know that a circle is the set of all points in a plane that are a distance r from any given point to the center of the circle. So we know that regardless of where I am, if I go from the center to the edge of that circle, it should be the same length. So this radius would be the same as, say, this radius over here. So all of those lengths will be the same, and so the set of all points around the circumference of the circle should be the same equidistance to the center. So we know that our distance formula from last year, distance is equal to the change in x squared plus the change in y squared. And so that distance formula is how that equation of a circle is derived, is that because it's the same distance between each of those points. So if we look at this picture here, so we have that this is my center, this is my k value, and then this is any random point. And so we're going to leave it as xy because regardless of where I am on the circle, it still is defined to be xy. So as far as the distance formula goes, if we make this into a right triangle, we know that from here to here, it's the difference between h and x, so that's x minus h, or we call that delta x. And the distance between here and here is the distance between k and y, or y minus k. And sometimes we call that delta y. So the distance formula is like our Pythagorean theorem. So a squared plus b squared equals c squared. So this would be a squared, which is that, and then plus b squared, which is that, and that should equal r squared. And so to solve for r, we just square root it. And so that's really just where that formula comes from. So our standard form of an equation of a circle is this formula right here. So this is something we need to know. Where our center is our h value and our k value, and then our radius comes from this side of the formula, which would be equal to radius squared. So just in general, just to make sure we kind of get that, so we're just going to do like a little example down here. Is if I have this equation, so my center, if I look here, is h and k. So h is what's adjusting the x, right, horizontal. K is what is adjusting the y, so vertical. So my horizontal shift for this would be -2. And then my vertical shift would be +3. So what affects the x, what affects the y? So this is my radius squared. So I know to find my radius, if that is the radius squared, then what numbered squared would give me 16, and that would be a radius of 4. Now we know when we do this, we would say that if I square root both sides, this would be the absolute value of r is equal to 4, but we know that the radius is positive no matter which direction we point it. So even if I say, what's this radius, we wouldn't say -4 because it's going downwards, it would still be +4. So then when I look into this equation, I have to be careful, right? So this equation, the radius would be +4, because we don't put r into the formula, we put that squared number. So that number times itself is what goes into the equation. Okay, so at the top here, we're going to do a solve it problem as an example. And then we have a couple more that we'll do on top of that. So we're going to squeeze this in here. So write the equation of a circle with the center at the origin and passes through -2 and 3. So one thing we have to kind of pay attention to here is that they tell us that the center is at the origin. And then they give us this extra kind of point. So this is a point on the circle. So the first thing we want to do is we want to actually write down what they gave us into a more concrete way for us to look at it so we know how do we write our equation. So that's our first step, is just kind of rewrite the information they give us into a way that's easy to understand. So we're going to list our given information. So we're going to list what is our center and any extra information. And sometimes that's a radius, sometimes that's a point, but we want to list this out so we don't get bogged down in what we have, and we want to make sure that we're using proper notation. So for us, our center, so I'm going to use C for center. Our center is at the origin, so that means it's crossing through on a coordinate system the middle of the graph, right? So that would be where x is 0 and y is 0. So there's our center, and we know that that's our h and our k value, right? So that's our hk. So our shift which is called our vertex on a parabola, or a start point on a line. So our center is our hk, so it's at the origin. And then the extra information they gave us, they didn't give us a radius, but they gave us an extra point. So I'm just going to say a point that they gave us was -2 and 3, so that's our x and our y value. So we're going to substitute in the information that we know. And in order to have an equation, I need to know my center and I need to know my radius. And I don't know my radius, so I want to find my radius. So that's going to be our second step, is we're going to find the radius. And so just for the sake of our equation, so if they want to know what the radius is, we would say that's r. But for the equation, we really don't want to know just r. We want to know what is r squared. So for us, when we solve, we're going to actually just solve for what is r squared, because that's what we need for the equation, right? So in order for us to do that, okay, we need to substitute in our given information. And we're going to substitute in our given numbers into the formula that we have, right? So this is our distance formula. Or Pythagorean theorem, so this is a squared plus b squared equals c squared. And then on our circle, right, change in x squared plus change in y squared equals r squared. In distance formula, the only thing different is that r would be by itself, so we would square root both sides. But for circles, we don't do that. Okay, so I'm looking here, so I know x and I know y, I know h and I know k. So I'm going to replace x with -2 minus h, and h is 0. Squared, and then y minus k, so here's y, there's k, and equals r squared. And I don't know r squared because I'm trying to find the radius, so equals r squared. So I just use this formula and then substituting in h and k and also the given point x and y. So this would be -2, 3 minus 0. So -2 times itself is a +4. 3 times itself is a +9. So then I know that r squared equals 13. So if they had asked for what is the radius, I would actually square root both sides and say r is equal to √13. And just for the sake of notes, I'm going to write that down. I don't need to know just r by itself, because if I look at my formula, they don't want to know what r is for the formula. They want to know what r squared is. So I know r squared equals 13, and I know my center. So those two bits of information will help me write the equation of a circle. So knowing the center and the radius, I'm going to go ahead and substitute in the values that I need. So x is going to stay x, y is going to stay y. So it feels like we're done, but we're not, right? So our actual answer needs to be the equation of the circle. So I'm going to do, get some room in here. So I'm going from here. So I have x as x. I don't want to plug the point in. And then h, which is 0. And then y minus k. And then equals r squared, which was 13. And then I don't actually have to have the zeros in here. So I could just write this as x minus 0 is x. Y minus 0 is y, and then that's my equation. So the reason I don't want to replace the x and y that they gave me is because this is not a unique point on the circle, right? On any circle I have infinitely many points, so there's a whole lot of values that for x and y that will work here. But there's only one center, right? There's only one place that it could be centered, and in this case it's at 0, 0, and there's only one radius, or radius squared in this case, that works, which is 13. Okay. All right, so let's go to the next problem here. So on page 223. So for this one right here, so we're going to do just the got it. So they're asking for what is the equation of a circle with a center of 5, -2, and a radius of 8. And so if I look at that, I know that my center, so again I want to list my information, right? So I can see it in a clearer way. So my center is 5 and -2. So that's my h and my k. And then they gave me my radius was 8. So they did not give me an extra point. So that might be, oh shoot, I don't have enough information. But if anything, this is actually better, because now when I go to put things into my equation, I don't have to solve anything extra. I can just write my answer. So if my radius is 8, then I need to know my radius squared for my circle. So 8 times itself is 64. So then this is enough information. And then all I have to do is put those values in. So my general equation right? So that's the equation of a circle. I know my h value is 5, k is -2, and I know my radius is 8. So radius squared, which goes in my equation, is 64. So I would do x and then -5 squared plus y. So now I'm going to have to subtract a -2, so that ends up being a positive. So y plus 2. And my radius squared is 64. Okay. Right, and then one more here, page 226. So this is for A. So this is page 226. And they got it here. So for this one, they want us to say, what are the center and radius of the circle with the given equation? So this time they give us the center here. So for this center, I've got x plus 8 squared, y plus 3 squared. So for my center, what affects the x is 8. So it's a horizontal shift of 8, but it's going to go left 8. Right? We do opposite there. And then, oops, I almost wrote plus. What affects the y is a vertical shift of 3, and it's positive 3, so that means I'm going to go down 3. And then I know from here that my radius squared is 121. So I have to figure out what number times itself would give me 121. So I can solve that by square rooting, and that would just be 11. Again, normally this would be absolute value, but the radius is always positive, so I don't need to do that. And so then my radius is 11. And then that's it for the bookwork. And we had one more short lesson on completing the square, but that will be in a separate video.